Kia ora everyone, I'm Lauren and today I'll be presenting the paper The Global Sand Shortage, a study of the role of glass in contemporary New Zealand residential architecture. So we'll start by going over the background of the global material crisis and sand shortage issues and the role of glass both historically and today. And then we'll look at the results of the case study analysis from this paper and what they mean for the architectural industry and what the key takeaways from this study are. So most people don't even know that we have a sand shortage, and it's acknowledged by comparatively few when it comes to sustainable futures in the building industry. Sand is second only to water as our most used natural resource, which is more than fossil fuels and biomass combined. We use it in computers, cell phones, cosmetics, roads, concrete, glass, and even paper, so it's incredibly important. But sand dredging processes cause major damage to ecosystems, coastlines, and habitats worldwide, drying up lakes and riverbeds and causing islands to vanish beneath the waves. The main driver behind the sand shortage is that desert sand is unsuitable for construction due to its roundness, which is caused by strong desert winds, and this means that sand must be extracted from ocean and riverbeds, which there is far less of and is far more destructive. One obvious solution is to recycle more glass and concrete, but global demand for construction and infrastructure is increasing exponentially, which means that recycling can't keep up. It can't meet global consumption requirements. And sand is a key component of glass and concrete, with more than 3/4 of dredged up sand being locked away in construction and infrastructure, which means the problem significantly falls on the shoulders of architecture. But contemporary New Zealand architecture is increasingly reliant on glass as the conveyor of our most valued possession, the landscape. So this paper contributes to the development of much-needed research that addresses the issues associated with the fact that in the near future, the construction industry will have to find alternatives to using glass as a herod material. Existing research on the sand shortage and its relationship to architecture tends to focus solely on alternatives to concrete, while glass is a much more difficult issue to resolve. Polymers are the only alternative to glass, but the increase in recognition of health and sustainability issues associated with them means that there's no commercial product alternatives to glass in the marketplace. And global sand consumption isn't adequately quantified due to it being an open pool resource. Hardly any countries regulate its extraction, and when they do, it becomes subject to illegal trade and extraction, such as Singapore illegally importing sand from Cambodia for reclaimed land. So this shows that sand consumption research must be accelerated so that we can generate more accurate data and reliable sources. Currently, standard tools for quantifying the use of sand for construction don't exist, which means quantifying sand usage in buildings isn't a priority for designers or construction industry professionals. So this paper reports on the original development of a tool that hopes to raise awareness of the topic as a starting point for future studies. The tool developed for this study involved measuring the sand usage of a number of residential case studies in New Zealand from 3 categories: award-winning buildings, passive houses, and standard spec design and build houses. The award-winning houses were selected for their relationship to the environment as a design driver and their success at capturing the view through openings. We also chose case studies from opposing regions like Otago and Northland so that the effect of the climate could be compared. And other factors such as varying sizes and architectural firms also played a part in the selection. So to analyse the sand usage of the case studies, we measured the windows using the construction drawings of each house and then used a standardised thickness of 4mm to find the glass volume. All the case studies were double glazed except for the passive houses, which were triple glazed, and the glazing factor is accounted for in the total sand content but not the glazed area. We calculated the glass weight by multiplying the glass volume by 2,500 because 1 cubic metre of glass is 2,500 kilograms. And then we found the total silica sand content by multiplying the weight by 75%, which is because about 75% of the glass recipe in New Zealand is actual silica sand, and the other parts are recycled glass, soda ash, and limestone. And then we multiplied the sand weight by 1.53, which is the factor to find the volume of sand from its weight. Because the case studies all had quite different floor areas, we represented the sand content per square metre in one column, and then also the total glazed area of the building as a percentage of its total floor area in the last column. So here you can see both those values represented, the glazing as a percentage of the floor area in the column graph, and the silica sand content per square metre in the blue line, which shows the impact triple glazing has on the sand content. But this actually showed that passive houses in the dark brown still tended to have lower sand content rates compared to the award-winning houses in the orange, despite having triple glazing rather than double glazing. Passive houses also tended to have more consistent values per square metre, which demonstrates that not only is it possible to have lower glazing ratios, but that maybe an optimal specific range of glazing ratios contributes to a building's sustainable success in terms of its net energy usage, which is a factor often overlooked in the media attention that award-winning houses get. The fact that most award-winning houses were closer to this end of the spectrum shows that architectural success in New Zealand homes tends to be represented by projects with big windows that use the landscape as a design driver. But there were some instances of architectural success while maintaining lower glazing ratios, such as Tim's Batch by Herbs Architects and Rafe McLean's Ko-Fi Passive House. The study also found that award-winning houses in the northern regions of New Zealand tended to have lower glazing ratios compared to their southern counterparts. This might be expected due to the higher average temperatures of the northern regions, which means they require less glazing to prevent overheating. And this presents a greater challenge for designers in southern regions when designing with less glass. This is a visual representation of the sand content in some of the case studies. Lindis Lodge had the highest sand content with 4.3 cubic metres of sand, and not only in total but also as a percentage of the floor area, while Tim's Batch was the best performing award-winning house with just 0.3 cubic metres of sand. But even if Tim's Batch had the same floor area as the Lindis Lodge, its sand content would only be about a quarter of the Lindis Lodge. The Lindis Lodge had a huge glazing area to floor area percentage of 66%, while Tim's Batch was only 17.5%, yet still demonstrated that architectural success by winning a NZIA Local Architecture Award in 2011. So overall, this study set an example that architectural success can be achieved with a glaze area of less than 20% of the floor area. And there's just some quick indicative models of what a 20% limit could look like on some basic forms. So the key takeaways we learned from this study is that designing buildings that are architecturally successful is possible with significantly less glass. But more tools are needed to be able to fully quantify the sand shortage issues in the construction industry, and this paper hopes to inspire future studies in that area. However, this study was able to set a clear and measurable target for designing with less glass, the 20% ratio we talked about before. And finally, more work needs to be done to bring sand shortage issues to light in the architectural community. Thanks everyone for listening.